Hi, this is a review for the first semester exam for Algebra 2, specifically information and standards that were in Chapter 3. In Chapter 3, the first standard that I'm going to look at is the simplifying standard. So if you look at questions 16 and 17, those are questions that have us look at the simplifying standard. And again, we saw this in the previous chapters, but when you see two sets of parentheses, you're going to distribute just the 3x to the first one or one of them. So I'm going to get 3x squared plus 9x, and I don't change the second parenthesis, and then I'm going to distribute again. So now 3x cubed minus 6x squared plus 9x squared minus 18x. And now I'm going to combine like terms. 3x cubed plus 3x squared minus 18x. And that's my equivalent solution. When it says verify graphically, that means we're going to plug this into our calculator and this into our calculator and just make sure that they're the same graph. And I'll show you that in a minute. Again, when you have something that has 3 parentheses, you're just going to distribute the first two together. So I would get 70 plus 10x minus 21x minus 3x squared. And then I still have the second set of parentheses. I would combine like terms first so that I have 70 minus 11x minus 3x squared times 8x times 8 plus 6x. So you just distribute the first two together and then you do this again. So then I do the 70 times the 8, so that's 560, and then I continue to go. So 560 minus 88x minus 24x squared, sorry, I'm running out of room, plus 420x minus 66x squared minus 18x cubed, and then I would combine any like terms. So my final answer, number 17, is 560 plus 332x minus 90x squared minus 18x cubed. Again, to verify, you just plug in your final equation into your calculator and the original and see if they're the same graph. The other questions from Chapter 3 that are simplifying are, if you flip to a few pages on to problems 35 and 36. So these are two other questions that do the simplifying standard. Again, zeros are x-intercepts. And it says just write the cubic function as a product first of factors, and that's all we're doing. So when it tells you you have an x-intercept of -3, that means you have a factor of x plus 3. If you have an x-intercept of 0, that means you have a factor of just x. And if you have an x-intercept of 1, that means you have a factor of x minus 1. And so all they wanted you to do was write this as a product, meaning all these three are multiplied together. And the order doesn't matter. You do the same thing for 36. If your x-intercept is a positive 4, that would be a factor of x minus 4. If it says it has a multiplicity of 2, that just means that there are 2 of them. And then if you have an x-intercept of x minus 2, that gives you a factor of x plus 2. So those are two more simplifying standards. In 36, you could also write this as x minus 4 squared, x plus 2. So in Chapter 3, we then, again, we wrote them first, sometimes we distributed them, etc. The next standard that I'm going to look at is the graphing standard, standard 3 for Chapter 3. So I'm actually going to flip back to question number 24. Question number 24, again, standard 3, you just have to sketch the graph of x to the 4th. X to the 4th we know is positive, And so if it's positive, that means that this side is going up. Since it's an even exponent, we know that that side is going up. So that's a general sketch. There are some others as well. But then it says list your end behavior, and that's just describing the arrows. So what we did is we said as x approaches infinity, so as x goes to the right, your graph goes up. So this represents going to the right, this represents the arrow going up. As x goes to the left, so when we talk about x values, we're talking left and right, your y values also go up. So again, that's how we talked about end behavior. If you look at the next two problems below or on the next page, 25 and 26, it was just saying determine whether the function by each graph has an even or odd degree or exponent. So again, this one had an odd exponent, and the reason that it's odd is because these arrows are in opposite directions. This one would have an even exponent because those arrows are in the same direction. So those are just some characteristics we talked about with graphs in Chapter 3. The next two problems on this page are graphing questions again, similar to what we've seen in our previous two chapters. So looking at 27 and 28, it says use reference tables, then graph the function. Again, this is x to the fourth. If you wanted to make your own reference table of x to the fourth, we went from -2 to +2, and then because it's x to the fourth, it's 2 to the fourth, 1 to the fourth, 0 to the fourth, 1 to the fourth, 2 to the fourth. In this case, we are just shifting things to the right one. So all that does to our transform table is add 1 to the x values. So y does not change, and you're just adding 1, so it's -1, 0, 1, 2, and 3. So if I'm just moving this graph to the right one, all of these points get shifted to the right one. And the graph looks the same shape as before. Here, this is a cubic function. Again, cubic function, when we wrote our reference table, -2 to +2, we were cubing it. So this gave us the -8, the -1, the 0, the 1, and the 8, as we see on the graph. This one just tells us that we're moving down 3. So in our corresponding table, x's are not changing, the y's are just going down by 3. So -2, -1, 0, 1, and 2, down by 3, -11, -4, -3, -2, and +5. So it's again going to your graph and just shifting everything down 3. Just paying close attention that this one does not count the same way. And so we would have a graph that shifted down 3. If you flip to the next page, there's some more on graphing. Oh, the one piece that I forgot was to talk about whether it was even or odd. Obviously, we can look at the exponent, but this one would be even, and this one would be odd. Again, same arrows in the same direction. Also, if you looked at the exponent, it makes sense. More thoughts about graphs in question 29. It says list the possible extrema or mins and maxes. If you have a third degree, we said that you could have a possible of 2 mins and maxes, and then it went down by 2. So if you think about your third degree, either it looks like this, where there are no mins and maxes, or it looks something like this, where there are 2 total mins and maxes. If you have a degree of 8, that means that it would be 7, and then it would go down by 2. So we talked about extrema in this chapter. Other things that we talked about for standard 3 were being able to sketch a graph. So it says use the coordinate plane to sketch the graph with the given characteristics. If it's not possible, explain why. So if it's even, we know our arrows are in the same direction. So it could either look something like this or something like this. If it increases until you get to this value, then decreases when you get here, then increases, then decreases. So you think about that in terms of a shape. Increase, decrease, increase, decrease. It's got to look something like an M, and that works because they're in the same direction. The lowest its relative value is going to go is 1. So I'm going to guess that this point has to be 1, and the maxes that it has to go are going to be 4. So it looks something like this. In question 32, again, even degree. And it says even degree in positive A, so something like this, has 6 x-intercepts. Okay, so it would have to go 1, 2, 3, 4, 5, 6, something like this. And then it says it has an absolute max. Well, because the arrows are going up, you can't have an absolute max, so this one is not possible. There are just a few more graphs on the next page that cover Chapter 3, and those are questions 33 and 34. If you look at the next page, these are just multiple choice. We saw some of these again in a previous chapter as well. So we see that this is a odd function because it has arrows in opposite directions, so it cannot be this first graph. We also see that on the right side the arrow is going down, so that makes it a negative function, so it cannot be the second equation. So the third equation is the only one that makes sense. Again, the odd comes because there's 1, 2, 3 x's. In question 34, we see that it's even, so it cannot be the third one. And then we see that there are 1, 2, 3, 4 x-intercepts, so we need to have the first one because it has an exponent of 4. This one would only have an exponent of 1, 2. So that wraps up all the questions in terms of graphing for Chapter 3. The only other thing that we saw in Chapter 3 was our apply standards. So we're going to actually flip back to question 15 and go over that one next. So in question 15, this is our apply standard. We saw a whole bunch of examples like this where we were looking at boxes and we were creating expressions for the box. And so again, if you think about the box, it was folding up the sides so that you had a height for when you folded it up. So we're kind of looking at a box that looks something like this. And it kind of tells you expression already. So if the height is 1, then you're subtracting 2 little corners, so it becomes 6. If the height is 1.5, you're subtracting 3 from each side, so the height or the width becomes 5, and then it's 4, and then 2. If I subtract out 4, there's nothing left for my width. Again, they gave me the expression for the length of my box. It was 10 minus the 2 corners, so this became 8. I'm taking out 1.5 inches, it would be 7 and 6 and 4 and 2. And then to find the volume of your box, it's length times width times height. So you're just multiplying the 8 times the 6 times the 1, and you get 48. Multiply the 7 times the 5 times the 1.5. 48 again, 24, 0. So again, it's the 3 expressions multiplied times each other to find the volume. So this represents the volume. This represents the max according to the table. You would graph this volume in your calculator and use your maximum feature to find the maximum volume overall. So 15 wraps up this Chapter 3 information. If you have any questions, make sure that you come in and see your teacher. Thanks.